talked about how to do menus yesterday, and then we want to talk about dialogues today. So we're going to talk a little bit about dialogues. We'll go over how to use the date and the time pickers, which also can be kind of displayed as dialogues, or they can be used as controls. And then we'll talk about, well, okay, given that we have those date and time pickers, how do we actually deal with dates and times in Java? Because that's actually not a simple topic or a simple question. Okay, so dialogues in general is anything that appears kind of above your screen. Okay, so we have the regular activity screen that you have. You'd have a dialogue up on top of that. Anytime a dialogue appears, you're going to see something like this, where you got the window kind of floating and the rest of it's dark. Right? So you can click the darkened area generally and dismiss it, doing basically canceling it, or you can click one of the options and say, okay, yes, I want to move forward with this. Okay, so we can use these dialogues in a lot of different ways. So on the left, and I'm working from left to right, we've got the time picker dialog. So you pop this up, say, hey, I want the user to pick a time. And this is just the time portion, not the date portion. So pick a time of day. We'll get that with the clock and AM, PM, et cetera, would be okay. Or let's say we want the user to pick a date. Well, then we get a dialog like that. Okay. If we want to have users say, see, we've got kind of do you want to agree to the terms of service of this application or not? So we've got agree or disagree, right? Do you want to allow the application to do this, or do you not want to allow the application to do this? If you're saying maybe go back, you're trying to leave a screen, you're writing an email, you might see something like this. We're saying, are you sure you want to discard that draft? Are you sure you want to throw it away? So anytime we delete something, this is a really good thing to do, is throw up a dialog. If we're about to delete something, we just say, are you sure that you actually meant to do that and you didn't just, it just wasn't just rolling around in your pocket, right, and pushing buttons, or you accidentally clicked on something. And then we see another one here where we've got a group of radio buttons, so they're given the option of picking one thing. So in this case, I think this is picking up one. Or we have another case here. We're saying, hey, well, which account do you want to use to log in, or in this case, back up your data? So there's a lot of places that we can use these dialogues. Okay. So general alert dialog has three parts. So the first part on the top is what we call the title. That part is optional. You don't have to have a title. Below that, we have what's called the content area, which is where you're kind of going to put your message. You're going to tell the user what are they agreeing to, what are you telling about them, are you sure you want to do this, what is that text. And then finally beneath that we have the action buttons, like what do you want to, what are your options, right? So that might be an okay cancel. Here it's cancel or discard, disagree or agree. So what the text of those buttons is varies quite a bit. Okay. The general recommendation with the title versus the alert versus like the content area is that most of the time you should actually have a content area and maybe not a title, because you really only need the title if you've got either a long message or if you're using some other kind of controls in the middle, right? So if you have a list of radio buttons like we saw previously here, well, we need to tell the user what they're actually doing. So in that case, it makes sense to have a title. There's enough text here, so there it makes sense to have a title, but for something short, maybe it doesn't. Maybe the message is good enough by itself. So if you have a message that's only one or two sentences, you may be better off just having the message and not the title. Or if it's something that's like, hey, are you really sure you're going to do this? This is going to delete your account for forever. Well, Maybe we want to have a nice bold title to tell the user, hey, this is going to happen. Pay attention. Now, the action buttons, the way that Android categorizes them is we don't think about OK and cancel buttons. Okay, the way we categorize them is positive, negative, and neutral. Okay, so typically your OK and cancel, your OK button's your positive, yes, I want to do this. Cancel would be negative, no, I don't want to do this. That makes sense? Neutral's kind of somewhere in the middle where maybe, or maybe later, right? Maybe not at this time. So that's how we kind of think about the buttons that go down there, right? So they can be any text, but the way that we need to think about them is this the button that says, yes, I want to do this, or is this button saying, no, I don't want to do that? Okay. So the way that we build up create these dialogues, we don't actually use the dialog class or the alert dialog class directly, because that would require quite a bit more code. So instead what we use is something called the alert dialog builder. So this is kind of follows what we call a builder pattern, builder design pattern, where we use this other object to construct the thing that we want. Okay. So we're going to say create a new builder. Okay. I'm going to save this to a variable called alert dialog. Note that even though I call this alert dialog, it's not actually a dialog, it's a builder for the dialog. It's the thing that's going to make the dialog. But it's not actually the dialog itself. Okay, so we say context is the main activity. Alert dialog, we're going to say set the title. We'll probably pull that from some resource file somewhere from the string. So set the title, set the message. If we don't want to set the title, then we just don't call set title. So if you don't call set title, then you have a little dialog without the title. Simple as that. So that's where you start. The next thing we need to do is tell it what to do with the buttons. Okay. So there's three methods we can call. We can call set positive button, and that says, okay, yes, I want to have a positive button, and here's the text and the code for it. Same thing with neutral and negative. So if we want to say, yes, I want to have an OK button, the first thing I need to give it is what string to show, what text to show. So here I've just said alert OK. Right? I have a little string that says, okay, we're going to put OK there. So the string, and then we have a handler, listener, that's saying, here's the code I want you to run when you click OK. That make sense? The same way for the negative and the neutral buttons. So that's how I add a positive button. If I want to add a negative button, then I need to call set negative button. If I don't call set neutral button, then I don't get a neutral, etc., etc. If you don't call that specific method, then that button doesn't exist. So it actually has to have a listener or some code to do, some code or action that it's going to do when you click that button for it to have that button. Okay. And then finally, once we've set it up, we need to tell that builder we need to call show. That's what finally puts it on screen. If you don't call show, then you won't actually have the dialog on screen. Now, when we call show, if I remember right, it does actually return, at that point, that's where we actually create the dialog, and that's what returns the alert dialog object. So if we need to work with the dialog after it's actually been shown, we need to save that return value from there. Or actually, I'm not sure, but I know you can at least get dialog. But typically, that's the point where it gets created, is on show. So pickers. Okay. So if we want to have date picker, time picker, these are the two classes that we're going to use. So date picker dialog, date time picker dialog. There's also two classes named date picker and time picker. So the date picker and time picker widgets, those are just ones you put in and they become part of the layout. That makes sense? So you can't actually use those outside of a dialog. The problem is outside of a dialog, they're generally too big on phones. So it can be okay on a tablet to have those date and time pickers just in your layout. But for sure for phones, they really do need to be in a dialog. So to just kind of keep things uniform, we usually just go ahead and put those in a dialog all the time. Does that make sense? Rather than having one version for tablets and one version for phones. So the way I use those two classes, so here I've got a method. This would probably be responding to when I click some sort of button. I'd say when I click a button, then run this code, right? So think of this as your kind of on-click method. Okay. So the first thing I'm going to do in here is I'm going to call calendar.getInstance. Okay. So calendar is one way to deal with dates and times in Java. And it's one of the older ways. It actually dates back to Java 1.1. So it's been with us for a really long time. But new instance says, hey, I want a new object. It's what we call a factory method. Follows that factory pattern. But it will give us the current date and time. So what I've got here now in cal is this calendar object, which represents the current date, time, as well as time zone. Does that make sense? So what I have is the current, basically, local time. Okay. Next thing I want to do is create this date picker dialog. So to create the date picker dialog, I need to pass in a context, which is the activity. I need to give it some sort of handler to say, when the user picks a date, here's what I want you to do. Okay? And then we finally need to pass in what year, month, and date that we want to be selected initially. Does that make sense? So if you leave these out, you don't specify the year, month, and day, it will default to the current year, month, and day. But what you're going to find most of the times is, hey, we need to initialize it to whatever the date that users currently entered, or we need to pull it from the database or some other way, right? So usually you're going to have to initialize it to some other date, set it to another date that's not just the current. Does that make sense? In that case, all you replace is that. We just get our calendar, our current time somewhere, that time somewhere else. So we create the date picker, we call show, that's it.
In the code labs, they have you do a lot of work with fragments and listening to.
Yeah. So let's go over this quickly. But yes, they do talk about fragments. They actually tell you a lot of stuff that you don't necessarily need.
Right, because it seemed a lot more compact.
This is a lot more compact. Do it this way.
Okay.
I'll go over that briefly. We'll talk about fragments and dialog fragments here in a minute. But if you want a time picker or a date picker, follow these code snippets instead. Because it already does all the stuff that they're telling you to do built in, without you having to write all that code yourself. Okay. And then the next thing we have is the time picker. Basically the same thing. Instead of using a date picker dialog, I use a time picker dialog. And at that point, I needed to give it three things. So same thing as earlier: context, handler, but now I need to give it the hour of day and the minute. And I need to tell it whether it's a 24-hour clock or not. So here I'm saying false is this is a 12-hour clock, true would be it's a 24-hour clock. So you can see in both of these examples, you see I'm calling calendar get instance to get the current time. Note what I'm doing though to pull out those individual pieces, right? So to pull out an individual piece of the date and time, I need to call get, and then I use these constants. See that? What does that look like? Looks awfully similar to maybe a map of some sort, right? So that's the way that the calendar basically works. You can think of it as a big map, a big hash map. You kind of say, here's the part of the time that I care about, and you can call get to get that individual piece, or you can call set to change that piece. That make sense? So I can call get to get the year. If I wanted to set the year, I can say set year and say, oh, I want to set it to 2014. So does that make sense? A few things to pay attention there too. Notice I'm saying year, month, day of month. There are some other constants in there. You do have to be careful which ones you use. So specifically, that day of month is not day of year, for instance. It's what day is it within that month. Or here, I say hour of day. Hour of day gives me as a 24-hour clock. So 0 to 23. If I just say hour, I'm getting it in a 12-hour clock, which would be 1 to 12. Does that make sense? So because this one specifically, when you're creating that time picker, it does expect it always as a 24-hour clock, regardless of whether this is true or false. Regardless of whether this is true or false, this needs to be 24 hours. Does that make sense? So that's one thing to make sure that you do in there is use hour of day, not just hour. Okay, so yeah, so you're asking about dialogue fragments and such. So if you want to build your own general sort of dialogue, right, and you don't want to use the alert dialogue, or you don't want to use the time picker dialogue or the date picker dialogue, you can make your own dialogues, okay? The way that we do that is we use the dialog fragment class, right? So that allows us to actually create any sort of dialogue that we may want. Okay, we're not restricted to here's the title and the body and the action buttons. I can actually create anything. Okay. So that's really where I would use the dialog fragment, is if I need to create something different than those three.
Does it just depend on like what interface you implement on top of the fragment, or what will show up as the dialogue?
So essentially, you're really kind of creating your own layout. Okay. Once you get into a dialog fragment, really, once we're talking about fragments actually have their own layout files. So anytime I create a fragment, I kind of like remember in an activity, what's that first line of code I have to write? Set content view, give it the ID of the layout. We actually do the same thing with the fragment. Okay. So in general, a fragment is any sort of area of the screen where we want to put some controls. Okay. As they say, it's kind of like a mini activity, right? So an activity is the entire screen. A fragment can just be a part of the screen, right? Think partial view, right? Partial view, we put those in the middle of our pages. Fragments are the same idea. So a fragment is kind of a smaller piece of that activity. And the upside of using fragments is you can potentially use them on more than one activity, or you can use them in more than one layout. So one of the places that fragments are really helpful let's say on a phone, right, I want it to say I have one screen that is a list of articles, and then I have another screen. Once you click on an article, you go to, and it'll show you the body, the text of that article, right? So you basically have the list and the detail page. Does that make sense? So you have two screens there, right? Now on a phone, that's really the best I can do, right? Those need to be two separate screens. There'd be no way to fit those things on the same screen. But on a tablet, right? Tablet has a lot more space, right? In fact, if we look at your 7-inch tablets that you have, they're basically, if you turn the landscape, you could kind of divide them down the center and you'd have enough space for two phones, right? So what we can do on a tablet is we can actually combine those. So we can have, here's the list on the left side of the screen, and here's the detail. Here's the actual text of the article on the right side of the screen. Does that make sense? So that's something we can do on tablets with the additional space. So the way that this works, if we want to set something up like this, well, with the tools that we've given, right, we can do a separate layout or a different layout between phones and tablets, but it becomes extra awkward because I have some functionality on this screen, some functionality on that screen, and then I'm saying for tablets, well, I want all that functionality in one screen. So just changing layouts does not work really well or at all for that. Does that make sense? So what we do instead is we say, okay, my goal here is I want the functionality for the list, the functionality for the detail. Well, what if I treat that as part of the screen? What if I treat that as a fragment instead of the entire screen? So I extract everything that was in this screen, everything that was in that screen, and I kind of move that logic into a fragment. Make sense? So now I'm displaying the list fragment and the detail fragment on one screen, and I'm displaying the list and the detail on two separate activities. Okay. So that way, again, the logic is in the fragment instead of being in the activity. Okay. So that's one of the reasons that we use fragments, right? Because we want to, especially for tablets, we may want to take more than one screen and move them into the same screen. It's also possible that we may want to have some functionality that exists on more than one screen, right? More than one activity. That also lets us do that. That makes sense? So that's where fragments come up, okay? That's the main reason we have fragments. But when we're talking about a dialog fragment, we're talking about this fragment that instead of appearing as part of the screen, is appearing on top of the screen as a dialog. Does that make sense? Okay. Now, fragments, regardless of whether or not they're a dialog fragment or just a regular fragment, they always have a layout. Okay. They're treated, again, like a mini activity. So you get to assign a layout to that fragment. So it can have everything in there. Now, fragments do also have some of those lifecycle methods, right? Remember with activities, we have on create, on resume, on start, on pause, on stop, on destroy. We have all those 6. Well, some of those also exist for activities, for fragments, because they're kind of mini activities. Now, the issue there, they don't actually, unfortunately, get all of them. So they kind of live in, unfortunately, fragments live in a weird world where they have kind of a life cycle, but unfortunately, the life cycle of the activity is usually not shared with the life cycle of the fragment. So working with fragment life cycles actually gets really interesting, in many ways painful, to be blunt, because there's a lot of weird things that happens with the fragment life cycle, because they're not really synchronized with the activity life cycle. They can, again, because they've got their own layout, they can have all of their own controls, and they can have input events that they get from those controls. And also because of how they now work, they can be added or removed from your activity. So you can say, okay, well, initially we're only going to show the list screen. Then when you use your picks an item, then we'll show both. Right? So we can say, okay, change the size of the list fragment and add the detailed fragment. So we can actually dynamically swap in and out fragments. One of the things that means, though, is that really the lifecycle methods that we get on fragments are tied to us adding and removing them, not when the activity is created, destroyed, etc. That's kind of becomes part of it. So does that make sense? You kind of understand what a fragment is? Again, the idea there is it's sort of part of an activity. It's a mini activity. In many ways, it behaves like an activity, but it's not actually an activity. Okay. So one way that we can use that is we can say, let's create a dialog fragment. And then the way that they're doing this is saying, okay, we'll create a dialog fragment and put a time picker control on that dialog fragment. Okay. That's what we get. So does that make sense? So you really only need to go through the dialog fragment if you're making your own sort of dialog. Does that answer your question, Evan?
Yeah, it was just the bane of me working ahead. I was just a little bit confused on how everything kind of pieced together.
Yeah. So they're telling you to do something a lot more complicated than what you really need to do because it's already built in. And I don't know why they did that, because on this first slide right here, they already had you linked to the date picker dialog and the time picker dialog, which are the finished versions. So I don't know why they did that. So anyway, that kind of talks a little, that's a little bit of how you work with dialogs. So the main three kind of standard dialogs you have the alert dialog, the date picker dialog, and the time picker dialog. Those three dialogs will fill most of your needs. Okay. The only time you need anything else is if you're putting a layout in the kind of in that content area, is where you might need to do something different. But I would recommend to you more often than not, if you need a dialogue more complicated than one of those three, it probably should just be another screen, or should probably be part of your screen rather than in dialogue in the first place. So let's talk about the history of dates and times in Java. So dates and times in C#, if you remember right, was pretty simple. There's a DateTime class, and we just use that DateTime class, right? There's also time span in there, which comes up occasionally, but it's the DateTime class. So good, because on that note, well, basically Microsoft did pretty good. They got there, when they first built it, they basically got it right. Unfortunately, Java wasn't so lucky. Their first stab at this was pretty bad. Really, really bad. So originally in Java, going all the way back to Java 1.0, what we got was the Java util date class. Okay. Now it's important that you remember the namespace there, Java util date. The reason is there are three classes in Java with the name of date. Not one, but three. Okay. So this is the old one. It's in Java util date. There's another one in Java SQL. It's a Java SQL date, right? Which actually is a subclass of this, but works differently, and you can only use it for SQL. So do be very careful as you're working with these. Pay attention to the namespace, because that's really, really important in this case. Again, because there's classes with the same name in more than one namespace. Okay. So this originally was all we had. Java 1.0. We had the date class. That was it. Okay? And with that, the date was stored as the number of milliseconds since the Unix epoch. That's how we stored our date time. So Unix epoch being January 1st, 1970 at midnight. Right? So if you have a time for 2020, say 2020 at 12 p.m., well, the way that's going to be stored is how many milliseconds is that from that time. Okay. It didn't support internationalization at all. It didn't support time zones, which is kind of a weird thing, because it's like, okay, well, you're storing it this way, so inherently internally that's kind of time zone agnostic, but then the only way to look at the parts, year, month, day, time, etc., the only way you could look at that was in the time zone of the device that it was running on. You couldn't look at it in another time zone. I couldn't say, okay, this is the time here. Well, what time would it be in Eastern time or Western time? It doesn't allow you to do that. Okay. So come Java 1.1, they said, this was really bad. We're sorry. Here's the calendar class instead. Okay, so the calendar class instead has a date, time, and time zone info, all kind of mixed together. You can't actually break it up and say, I only want the date part, I only want the time part, or I don't want the time zone. You always get the whole mixed bag. And the way it stores it is kind of as a map between the part and the value, right? So you saw the sample code that you saw a minute ago. I use get and then the constant for the name of the part, and that gives me the individual value, right? So if I want to say get the second, I'm going to say, or within the minute, I'm going to say, take the calendar object called get and pass in calendar dot second, right? So that's how I get out an individual piece. Similarly, if I want to change a value, I call set. Okay, now there are cases because of how that works, because as a map, there are things that conflict with each other. So for instance, remember there's hour and hour of day, right? So there's a 12-hour clock and a 24-hour clock, right? So you would expect if I change the value of either of those two, doesn't it need to change the other value to keep it in sync? It doesn't, right? So actually if I say set hour of day or set hour, it doesn't actually change the other side. It leaves it whatever it is. So if I want to change the hour of day, I actually have to set both of those things. And potentially AM, PM as well. That's it. So it's got some kind of weird inner workings as that is concerned. Okay? And the way it stores it. It does support internationalization. It does support time zones. But it doesn't make our math easy. So you remember in C#, remember we could add dates, we could subtract dates, calling add and subtract, right? Or add days, add seconds. Calendar doesn't have any of that. So calendar has no math methods. I can't say what's 2 days in advance, what's 2 days from now. So the best thing I can do is I can say get the current date, add to, and then save it back. That's the best kind of solution I've got for that. In both of these cases, both the date class and the calendar class, these are immutable. These are mutable objects. So I can, I get the time, and I can change it. Which also means I can do weird things like say, hey, I want to get the person off, the user object, right? And maybe it's got some sort of timestamp on there that says when they register, right? Maybe I've got a getter that returns the date and time for when they register. Well, I can get that calendar object and change it. There's no preventing the user from modifying those dates. So if I'm going to use that, I oftentimes end up having to write my objects, my data objects in a way that if they were going to return a calendar object or a data object, that they need to return a copy so that I don't get my data all mixed up, right? So there's a lot of issues with those sort of APIs, okay? Another thing that trips a lot of people up, going back to the date class. So the date class represents year 0 as 1900. According to the date class, year 0 is 1980, which is really weird, right? Which means that usually if you're working with that date class and working with years, you have to add or subtract 1900. Because that just doesn't make any sense. On the other side, Gregorian calendar, which is a subclass of calendar. Calendar is kind of the general purpose. Hey, you want to represent any kind of calendar, then you use the calendar kind of base class. Okay? But we've got other calendars like the Muslim calendar is different. There's a Hebraic calendar that's different. So all of those, though, are subclasses of the calendar class. So the one we use most though is going to be the Gregorian calendar. That's the one that we are familiar with. And in that space, well, years are defined as, well, 0 AD, 0 is 0 AD. And that 0 is not 1900, 0 is 0 AD, which is what I would expect. Okay. Another weird thing between, so that can trip up your math, right? Especially if you're using dates and calendars and using them together. You can't take one and move it back and forth without converting it. Okay. If I'm working with either dates or calendars, the way that months are represented is also a common cause of error. Okay, in the date and calendar classes, January is the number 0, not the number 1, like everybody else and like everybody, all sane people do. January is 0, which also means that December is 11. So that can easily give you off by 1 errors. Because you say, okay, well, the user typed in 1, but now 1 is February, right? So this is something you have to be really careful about when you're working with calendars, when you're working with dates and times of year.
I want to say I wish it was off by 1 more, so that September, October, November, December could be the 7th, 8th, 9th, and 10th month.
Well, it's all there in between. It goes from 0 to 11, but yeah. So that's there. So one common thing that you may want to do when you're working with dates and times, I probably want to take them and turn them into a string. Okay. I probably want to take that date and time that I have and at some point represent it as a string. Okay. There are a lot of gotchas with the old APIs. Okay. So the way that we do formatting is we use something called the simple date format, which really isn't that simple. It was supposed to be simple, but it isn't. And it kind of goes back all the way to originally the days of Java 1.0, which means that it suffers some of those same problems that the date class had. Okay. In fact, the simple date format doesn't know how to format a calendar object. It only knows how to format a date object. Let me say that again. It doesn't know how to format a calendar object, only date objects. So I have to take my calendar object and I have to say calendar.getTime. GetTime returns a date object. GetTime returns a date object. Okay? So that's how I take my calendar object and turn it into a date object, which I need to be able to format it. Unfortunately, that means I then inherit all the problems with the date object. So I want to hopefully only have that date object for around as short as I can. I don't want to stay in that world any longer than I have to. So let's create calendar, say get the current date and time. We, again, get a calendar any other way, but I'm just getting the current date and time. Okay? So if you need to format a different date and time, change that first line. The rest stays the same. So I'm going to say simple date format, call this FM, and I'm passing in this string here, HH:MMZ. Okay? So that's the actual format string. Okay? And then if we look at the documentation on simple date format, it will tell you what each of those letters mean. So the uppercase H means the hour of the day as 24 hours. Okay? So uppercase H is 24 hours. What do you guess that lowercase h is? Okay. So you're right. Uppercase H is hour of day, 24 hours. Okay. lowercase h is the hour, but in 12 hours, 12-hour clock. So what about the m's? What would you guess that lowercase m is, given that I told you that that's the hour? Okay, minute. So lowercase m is minute. What is uppercase m?
Month.
Month. The new APIs don't make this any simpler. They do fix a lot of problems, but that's just something you have to be aware of if you're writing format strings in Java. Is uppercase h is different from lowercase h by that 24 versus 12, and uppercase m and lowercase m are very different, right? A month and a minute are nowhere near the same thing. Okay. Especially since we're dealing with dates and times. We're crossing between those two. And then the last letter that you see there, which is the Z, that Z is the time zone. So that Z is the time zone. So what I'm saying here, let's say the current time is, what time is it right now? It is 1:17, okay? So this would output, if I take 1:17 here, this would be 13:17, would be the first part, right? And then the time zone typically is outputted as the amount of hours and minutes that we are off from GMT or Central or UTC. So we might say -0, 600. So that's how you might see the time zone come out as -0600. Although that depends on whether we're in daylight savings time or not, right? So it may, some parts of the year it's -5 and other parts of the year it's -6. Okay. So that's what that's giving me now. Now, as I mentioned a second ago, this simple date format only outputs dates, right? Remember, a date doesn't contain time zone information. So if I just told it to format the date, it wouldn't have any of that time zone information. It would be just going off of the time zone on the device you ran it on. Okay? Which, if this came from the database, right, maybe this is somebody from India that filled in this date, that'd be an Indian time zone, but now it's outputted in Central Time, right? So one of the things I need to make sure that I do is on the simple date formatter, I need to call set time zone to set the time zone that I want to output it in. Okay, so here I'm telling it to output it in the same time zone that's in the calendar object. Okay. Now what that does mean, let's say I want to take whatever time zone that's in there and output it as Eastern Standard Time, right? I would just change this line of code here and set the time zone to Eastern Standard Time instead of setting the time zone to what it is in the calendar object. Does that make sense? So all of those steps you really have to remember to do. If you miss any of those steps in the process, you say, I don't set the time zone, or I don't use a date object here, your format won't work. Okay. Now, another very, very important note. Simple date format is absolutely not thread safe. It's probably one of the most thread dangerous classes that I've encountered, which is kind of crazy given how simple it should be. So if you try to format two dates at the same time with the simple date format, you will get garbage. You will get garbage. And we had that actual application in an Android application. We actually had that very problem in an Android application where we were storing, we had a bunch of simple date formats, right? Well, we assume, okay, here's the 3 standard formats that we're using for an entire application. So let's put those in static variables, right? Because we're gonna reuse those formats, right? So these simple date formats or objects we're going to use in the entire application. Well, what that meant is there were plenty of cases where 2 things tried to format a date at the same time, and both of them got garbled to the point that it was in unrecoverable data. We had times that were like 1900s and earlier. It's like, this is not right. Because two things where you're trying to use that simple date format at the same time. So what that means, whatever you do, don't put that simple date format in anything other than a local variable. Don't keep it around any longer than you have to. Don't worry about creating a new one every second. Go ahead and create a new one every second. It's worth the trade-off. So we only want to put these in local variables. We never want to put them in static variables. We never want to put them in member variables. What you can do is you can put this little string here, HM, HH, :MMZ, that format string, you can safely put that in a constant. But don't treat the simple date format object as a constant.
So what if you had that outside the for loop and then inside the for loop? You're trying to.
As long as it's a local variable, you're okay. As long as it's a local variable, it doesn't matter if it's inside or outside of for loop, you're fine. The problem is doing 2 things at once, having 2 threads operating on the same line. So as long as you're using local variables, that's already guaranteed. Pretty much. As long as you don't pass it to another method, right? So that also means don't pass a simple date format to another method. Never have that be an argument. So you understand what's going on here, okay? This looks ugly. Unfortunately, you're going to have to use it. Okay, so do take some time to learn it, understand it, because it's still, unfortunately, the way that we're going to have to work with dates and times in Java and Android right now. Okay, so there's kind of light at the end of the tunnel, which is good news. So in Java 1.8, Java finally, or Oracle finally came along and said, let's fix this darn problem, right? This is a really big problem. Let's finally fix it. So in Java 1.8, we've got 3 new classes: local date, local time, and local date time. Okay, all of these are now these new classes are all under Java.time. Remember the other 2 were in Java util. Okay, which Java util is also the same place where all our collections are, like lists and array lists. But these are now in Java time. So everything in Java time, actually that entire package was introduced in Java 1.8. So if you're looking for the documentation on the new time API, look in the Java time package. Java.time package. So that was introduced in Java 8, right? Now, remember at the beginning of the semester that I said there's this whole kerfuffle with Oracle basically buying some interns, basically buying Java, right? And in that interim, we also, while that was happening, we also had Android starting off and using Java. Well, for the longest time, Android was stuck basically on Java 5. Okay, it's only recently that we've been able to use the new features in Java, and we're still behind, right? So in Java, in API 26 or later, we can use all these Java 8 features finally. So if your app supports 26 or higher, you can use that. Unfortunately, that's not necessarily most of the market. Okay, so let's see. If we're going to look up the stats, let me remember. Yeah. Well, a lot of times you buy a phone and you can't necessarily upgrade to a newer version of Android on that phone. You usually have to buy a newer version of a newer phone to get a newer version of Android. There we go. So here's the kind of numbers that are put out by Google themselves, because they have an interest in keeping track of what versions people are actually using. So the only oldest version that people are still using in the industry, or sorry, that people still have smartphones for, is 10, which is 0.3% of the market. So 0.3% of Android phones are still using 10. Okay, so that's the oldest version that's out there. But that's a really low percentage. So you can see if I say 15 or higher, I'm only using a small portion. So safely, I pretty much say 16 or higher, and that's basically everybody. In fact, this is kind of where we're starting at 21, because these numbers are getting smaller and smaller. There's still a surprisingly high number of people on 4.4. There's actually still a lot of KitKat devices out on the market. In fact, some of the tablets that we just used last semester, most of those were KitKat as well. So there's a lot of these out on the market still. So if we look all the way down to 26, we can kind of add up those numbers, and we can see anybody that's 26 or higher, only like a third of the market, right? So there's only about 1/3 of the Android devices out there in the market can use these new date and time APIs. So take that with a grain of salt. Okay. These are much better. Unfortunately, you're really going to have to still target the old devices. There's not enough of these to really write your app just for a third of the market. Hopefully in a few years that will change, and we'll be able to use these in all of our apps. But unfortunately, there's such a big change, you can't really easily go back and forward and say, well, we'll use this we'll have part of the app use calendar. We'll use this for count for older versions, and we'll use the newer one for newer versions. Not quite so lucky. So a few things that they've done. So all of these objects are now immutable. The local date, local time, local date time, all three of these are now immutable. Okay? What does that mean? What does that mean for an object to be immutable?
It can't be edited, and if you did need to, you'd have to destroy the object and then recreate it.
Well, you don't necessarily have to destroy it, but you have to create a new object. Yeah, right. I can't modify the original object, right? What's one of those common objects that we've got in the Java kind of API that is immutable? Strings, integers. Actually, all of those basic types that we're used to, Java took the route of making those immutable. Oddly, they didn't take the route of making dates and times immutable. Who knows why? But they didn't take that route. So finally, these objects are immutable, kind of borrowing from the success of the string class. They also make math and time. All the math that we do with dates and times with them is actually really easy and actually pretty intuitive, because we've changed some of those things. So like year 0 is year 0. January is 1. So those things have been changed, and it's actually really easy to add to a date, because there's literally an add method. So you say add, tell the unit how much, and great. You say I want to add 2 days to this date. I want to add 2 weeks. Done, super easy. So that these are a lot nicer than what we had previously. They also in there they use a class that's also in Java.time called clock. And clock actually makes things work, is really helpful from a testing, automated testing perspective. Even just not automated testing, but regular testing, but especially for unit tests. Because what we can do is typically, let's say we want to test some code, right? And that code is asking for the current time. It's a really common thing to do. You want to ask for the current time. But if I'm writing a unit test, I don't want that unit test to be, the outcome of that to be based on what the time is when I run the unit test, right? Because I want to say, okay, well, I want to find out, does this code fail in the afternoon or does it fail in the morning, right? I need to test both of those things, right? And if I just say like calendar.getInstance, well, I don't have a way to tell it, I don't have a way to tell it that it should behave different, that I can't test those cases. Does that make sense? So clock gives me a way to kind of change and use a different clock than what the actual current time is, right? So I can kind of tell it that the current time is actually 11:35, or it's 4 p.m. in the afternoon. So I can actually use the clock to kind of change what the current time is. So that's the upside of it. It makes it a lot easier to test that kind of code that's based on the current time because I can kind of fake it, right? I can put it at whatever time I want it to instead of being forced to have it be the current time. So that's really helpful for testing. Okay. And the way that they store their actual data is actually pretty sensible, pretty simple. If you look into the implementation of these classes, here's the member variables that you'll find. So inside the local date, it's got an integer per year, a short per month, and a short per day. I think that's pretty self-explanatory, right? Really easy to read, really easy to understand. There's not going to be a lot of causes of like error. Okay? That's pretty simple. So that's how it stores it, just 3 integers, basically. Right? Local time's also on a similar note. So I've got a byte for the hour, a byte for the minute, a byte for the second, a byte for, or an integer for nanoseconds. You want to go down to that precise. Super simple. You'll notice that they're all marked final, right? Why are they marked final? What effect does that have?
And that what makes them immutable?
Yeah. That's really what forces them to be immutable, right? I could still have them be immutable without those because I could say I don't have any setter methods, I just have getters. But that really forces that there's no way to change that value, right? Once I create a local date object, past that point, once it's created, I can't change any of the values. Once I create a local time, I can't change any of the values. They're there, whatever they were when I constructed the object, that's what they will be. Okay. Similar note, local date time, which is a combination of those two, dates and times. Well, they said, gosh, well, we've already built a date class and a time class, let's just use those. So the 2 member variables inside a local date time is a date and a time object. So it stores the data really efficiently and in a way that doesn't cause all the issues that we had previously. Okay. Remember, going back to the date class, the way that one's stored is the number of milliseconds since 1970. If I look inside of the date class, there's literally just a long. That's it. There's a single long. That's how it stores the data. Which means that you also get interesting things like, I'm sure people heard about the Y2K bug, right? Well, there's another one of those potentially with how that date class works. Because eventually, if I store all of my times as milliseconds since 1970, eventually I run out of numbers. Eventually that has to roll over and become negative. And then that's a problem. But this doesn't have that problem, right? When does this year roll over? What's the max end? It's about 4 billion. Okay, so this will not have a problem until the year 4 billion.
Actually, I think isn't it 2 billion? But
You're right. It's 2
the
billion.
other 2 billion are negative.
Yeah, right. You're right, because it's signed. I forget. I'm signed. But it's about 2 billion. Either way, year 2 billion, this will work until year 2 billion without having any sort of Y2K problem. Huh? Use something then. Our computers will probably not look the same way that they do in the year 2 billion, if there even are computers.
There will be computers, they'll just be ruling the world.
We will be the computer.
I mean, maybe at that point they won't care about days and times anymore.
I'm pretty sure the Earth is not going to be a thing at that point.
So
It's stored in memory.
so there's a lot of things that can happen at that point. So that's good. And the other thing that then happens with this is actually formatting is super easy. So if I want the current date and time, I say local date time dot now gives me the current date time. No weird get instance, but hey. Now I can pass in a clock into now, and that's how I deal with the testing aspect. I just pass in a clock object into now, and it will use that clock instead of the normal system clock. So I get the current date and time, and then I say date time formatter, and then there's a bunch of different factory methods. So like I can get standard date and time formats, but here I'm saying I want to use my own pattern. So I'm saying of pattern, and I use that same format string I had previously. So that gives me a date time formatter. And then I say take now, my date time, format it, and give me that format. Yeah, standard string. Time zones dealt with, no weird conversion from calendar to date. All pretty sensible, right? And because it's all immutable, I don't have any of those threading issues that I have with simple A format. Okay, so this is hands above. This is absolutely better than the old APIs. So if you're writing anything in just Java, right, not Android, but Java, absolutely use this and convince your team to switch over to this because it's worth the benefits. Unfortunately, again, this is only introduced in 26, so for the moment, anything you do in this class with dates and times, you will more than likely use the old version because we're trying to support devices. That make sense? So this is the new way to do it. Keep that in mind as far as Java is concerned, but just know that unfortunately we're still going to have to continue with the old API. Any questions?
I just want to say that sun's going to destroy the Earth in 5 billion years.
The sun? Okay.
We'll be on another planet, so
If human society even lasts that long.
Yeah, that's a good question. Can we go 2 billion years without making nuclear war? I don't know.
I mean, we got really close that one time.
We got close a few times. We get close a few times. Yeah, there's a lot of crazy stories about what happened in the past 40, 60 years. If you want to read more about this, there's a really good article, and this is where I pulled some of my information, in fact, about why the date and time calendar object is core or bad and why you should use it. That's worth reading, even if you're still having to use it. Because it'll explain some of those downsides of that older API. Some of those gotchas. So that's really all I have for today. Is talking about we talked about dialogues, and then we talked about dates and times. That's really all I wanted to cover today. Any questions? So for the labs, bring these up. Actually, I should be able to just follow that link. Yeah. Okay. So for 4.3, yesterday you should work through task 1 through 3, and then the coding challenge. I'll be by to check those off. And then today you want to finish task 4 and 5, and coding challenge 2, and then bring back the homework assignment for tomorrow. All good?